Okay. Good afternoon, everyone. Thank you for joining my session on deep dive into high availability and disaster recovery features in Couchbase. So some of you who don't know me, I'm Anil Kumar. I'm a senior product manager at Couchbase. I'm with Couchbase for almost 2.5 years now. I started when we released Couchbase Server 2.0, and that was a significant release for the company because we transformed Couchbase from a key value store to a document store. And that was a release when we started supporting JSON documents, cross data center replication, views, MapReduce functions, right? So that was a significant release for the company. Followed by 3.0, which was last year, which was a complete architectural release, right? So we did a complete architecture revamp. So we had a bunch of significant architectural components we introduced in 3.0. So such as the database change protocol, tunable memory, incremental backup restore. So a bunch of these new technologies came up in 3.0. Now we are at the verge of our next biggest ever release, which is 4.0. The reason you guys heard in the keynote presentation this morning, the reason it's a big release is because we have a significant architectural change in 4.0, but plus also we have some developer-focused new thing, which is Nickel, which is a SQL-like query language, which is introduced in 4.0. So the architectural change we have in 4.0 is related to multi-dimensional scaling, which is I'm going to talk about in this presentation. And also we have global secondary indexes, we have spatial indexes, which are the new stuff which is coming in the 4.0 also. So in this presentation, I'm going to spend next 40 minutes talking about what are the high availability technologies we have in Couchbase, what are the disaster recovery features in Couchbase, and the way I would like to do this is by taking a real world example, right? And then going through the process of like how to make sure that your real world real world application has the high availability and it's safe from disasters, right? So the whole process of we'll have the first part of we'll go through the high availability. Okay. So first part we'll go through the high availability technologies, and then we'll go look at the disaster recovery features. So let me get started. So before I start talking about what technologies we have in the high availability, I will begin with this question, right? The question is, what does data unavailability means to your mission critical application? And as I mentioned, I would like to take a real world example. Let's say that we have an e-commerce application, and it's an online store, right? And it's an online store, and to emphasize on the business impact, let's say it's a Black Friday or a Cyber Monday, right? In this case, a few seconds of downtime means, in terms of business value, is a huge loss in the business in millions of dollars, right? So to avoid such kind of situation, right? What do you make sure is like you need to have your system very highly available. It should be able to recover from the disasters, right? So there are key principles of highly available systems, and the key principles are your system needs to easily scale on demand, right? Because let's say if it's a Black Friday and you need to have add more capacity, so you should be able to easily scale your cluster, right? And that's how your system will be available. You should not let your system to melt down, right? So first key principle is it should be easily scalable. Second principle is eliminate single point of failure, and the way we can do that is by adding data redundancy. So you need to have data redundancy within the cluster, so that in case a single component failure or a single node failure won't take the entire system down, right? So that's how we achieve the no single point of failure, right? That's the second key principle. The third key principle is detect the failure and recover from the failure. So imagine you have a production system of hundreds of nodes, and if a couple of nodes goes down, you need to detect this failure as quickly as possible so that you can recover from it, right? So your system should be able to detect the failures and recover from it, and it has to provide you the technologies to support that. And finally, we need to have your system should be able to recover from the catastrophic failures. So imagine you have a natural disaster such as earthquake or power loss in the data center, right? In this case, you should be able to have a geolocated cluster, which is a cluster which is somewhere in the another zone or another region, so that in case if your entire data center goes down, you have still the availability on the geolocated place, right? So this is how your system should be able to give you a highly available cluster, right? So now let's look at how Couchbase has addresses those key principles. So in this diagram here, so I'm going to talk about the single node architecture. And why this is important is basically when I talked about the first key principle, which is easily scalable, right? So there are many aspects of the database. The aspects are your database needs to be scalable, it needs to be available, it needs to be performant, it needs to be consistent. So all of these are tightly coupled together, right? So if you want your cluster to be highly available, you have to make sure that your cluster should be scalable also, right? So imagine going back to the real world example, if you have an online store and let's say there's an awesome deal on the Apple Watch, right? And everyone is jumping on your site to buy this, to get this deal. Now suddenly your traffic spikes up, right? And you had anticipated that you would have like 20 servers in your cluster. Now because of the traffic, you need to add some more capacity. At this time, if your system is not able to handle this more capacity, or if it takes a downtime, it's impact to your business, right? So your system should be able to easily scale your cluster without impacting your availability, right? So the single node architecture is the foundation for high availability, right? The reason I would say this is foundation is because it gives you an easy scalability. You can add more nodes. There's no master slave. There's no primary. There's no configurations to handle. So it's basically all the nodes in a Couchbase cluster are identical, right? And I think throughout this conference you'll hear about this single node type a lot. So basically the idea here is, if let's say in this case we have 3 nodes in a cluster, all the 3 nodes here are identical. There's no master. There's no slave. There's no adapter. No router, nothing. So it's basically all of them have the same processes running. Initially, if it was back in 3.0 or 3.3, which was our last release, you would see there will be a cluster manager, there will be a data manager, and the managed cache and storage. We introduced this 3 new stuff, which is data service, index service, and query service, along with the new architecture for multi-dimension scaling, which I'm going to talk about a little later. But that's the workload isolation we want to do. But the idea here is like still they are all single node type. Right? You have the same processes running, and the way the orchestration happens is, let's say there is an event such as a failover event, or one of the machine goes down. At that time, there's a master orchestration, which is basically there is an election process, and between these 2 nodes, one of them will be voted as the master node, and that's the node which will basically take the actions on the whole cluster, right? So the whole orchestration happens at the point of the event, at the point of when the event has to happen, right? So this is the foundation for this is foundation for high availability, easy scalability, and this is how we can easily grow your cluster. So you imagine going back to the application, if you have 20 node servers, and now you anticipate that you need a few more servers to your cluster. You bring in the more servers, you do a rebalance operation, which is data movement, right? At that point, your application is still going to the active partitions, so they are not. There's no effect to the availability. When all the other servers gets added to the cluster, that's only when the traffic starts going to them, right? So the whole process of adding more servers, adding more capacity becomes very feasible, right? So there's no downtime for your application. So next thing which I would like to cover is how do we achieve the data redundancy? So I talked about eliminating the single point of failure. It's like the idea here is like you need to have a extra copy of your data within the same cluster, so that in case if you have one of the machine goes down, you need to have the replica partitions on the other servers get promoted, and so they can start taking the traffic, right? So the whole idea here is like having the data redundancy within the same cluster, and also I'll talk about even if you have a replica copy, in case if multiple node goes down, what happens then, right? So in that case, I'll talk about the Ragzone Awareness feature, which is much more advanced high availability feature, right? So here, I'll talk more about how the replication happens in the next slide. Basically, it's RAM to RAM. The reason it's RAM to RAM is basically we want to make sure that the data which comes to the active partition gets sent to the replica partition as quickly as possible. The goal here is to send the data out so that so that we minimize the data loss, right? So in case if the server goes down, we want to make sure that the data is already there on the other node, right? So that's the whole idea of like RAM to RAM replication. You can create max of 3 copies, so totally we'll have 4 copies of your data in the same cluster. And one more thing, which is important to notice here is bandwidth optimization. So we are working on, so as I mentioned, like 3.0 was a significant release for us. We introduced some new architectural stuff, which is the DCP, which is Database Change Protocol. I think I have a slide on that next. So basically, the idea here is it's much more optimized. Let's say on the active partition, if there is a mutation, right? So a particular key gets updated, and within a fraction of a second or even fraction of millisecond, the same key gets updated again, right? So you don't want to replicate all the changes of this key to the next server, to the replica servers. So what we do is we do the deduplication. So we wait for, we make sure that if the same key gets updated, we send the latest changes to the replica servers. So that's how we optimize the bandwidth. But even with that, still the goal is to make sure that the data gets replicated as quickly as possible so that we have availability of the data. So let me show you the whole write operation in action, right? So here is an example of application server, and there's one single node of Couchbase Server. And there are multiple components here. The one main component here is the managed cache, which is the one which interacts with the client. All the interaction between the client happens through the managed cache, right? The managed cache is our in-memory database. That's the one which is basically taking care of all the sub-millisecond response time, right? The managed cache is basically, it's a memcached protocol. It's very efficient, and that's one of the reasons why we can achieve a very high performance, like sub-millisecond response time for most of the mission-critical applications. So here, let's do this. So as you saw, that application server wrote the document to the managed cache. So the documents came to the managed cache, and the managed cache at that time wrote the same document to two different queues. There's one queue on the DCP, which is the intra-cluster application. There's another queue for the disk, which gets stored, makes it persist to the disk, right? So this operations happens asynchronously. As soon as the document comes to managed cache, the goal here is to get this out to the other server and also persist to the disk, right? And because it's happening RAM to RAM, as I said, because it happens memcached to memcached, it's very fast, and we minimize the loss of data. Even in case of, let's say, if there is at the point when the document is in memcached, managed cache, and if the server goes down, right? So DCP has this new ability to see what it basically does is sequencing. So it does the ordering. So if every write operation to the server, the DCP knows exactly what was the sequence number for that particular mutation, right? If this kind of event happens where one of the document comes to the managed cache but it doesn't get replicated or doesn't get persisted, the DCP can figure it out that this particular document, the mutation didn't happen. So the acknowledgement doesn't get back to the application server, and now that transaction fails, right? So that transaction has to be repeated. But on the contrary, if there's other options, basically if you know for sure that you have a very important data set, a data set which you want to make sure that you have to persist it or you have to replicate to the other server, and only then you want a acknowledgement back to the client. The way you can do that, we have client-side SDKs, APIs, which is persist to and replicate to. On a key-by-key basis, you can basically say, I want to make sure this document not only gets persisted to my active server, but also gets replicated to the other server, and only then send me the acknowledgement back, right? So we can mention, as I put there, so we can do RAM plus replicated, RAM plus persisted, and you can do all of them, RAM plus persisted plus replicated. So it's basically waits till all this operation happens and only then sends a acknowledgement back to the client, right? So it gives you extra durability. It's like you guarantee that this data is persisted, this data is on the other server, only then send a response back. Another important thing here is, so DCP, it's a DCP-based queue, which I will talk about a bunch of new capabilities. I think I'll bring this slide here. So the DCP is a new, introduced in 3.0. It's a new architectural, as I said, we revamped the architecture. This is the heartline for the Couchbase, right? And in the entire system, the DCP is the heartline for all the downstream components. All the other components of the Couchbase, for example, the intra-cluster replication, cross-data center replication, backup restore, now the new stuff which we added in 4.0, which is global secondary indexes, connectors, all of them are consumers of DCP, right? So the DCP is kind of a bloodline for the whole system. So and as I mentioned, the DCP has much more advanced features, such as better resumability after blips and failures. It has ordering, it is consistent, it can take a snapshot of the point in time in the memory, so that if you want a consistent snapshot of what's there in the memory, we can do that. So all of this is the ability of DCP, right? Because of the DCP, which with all its capabilities, now we can do incremental map reduce, incremental rebalance, incremental backup restore. All these new capabilities are because of the DCP. So DCP is, again, we have also started externalizing it. So now all the connectors we are building, like Kafka, Scoop, Spark, are all feeding the data from the DCP, right? It's a change data capture, the CDC stuff. So it's basically any changes which happens to this server gets fed to all the connectors, right? So in future, right now we have Elasticsearch connector, we have Solar connector, which are basically using our XDCR topology, the cross data center technology. But in future, we will be changing it to, they will be basically feeding off from the DCP itself directly. So we have much more efficient, low latency, feed to those connectors. Any questions on the DCP or the write operations? Yes. Correct. So it's basically on a per key basis. So if let's say you have one particular key you want to write, on a per key basis you can say, I want to make sure this particular key has to be replicated and only send me the acknowledgement back, right? So it's much more efficient instead of saying I want to turn this on for the entire data set. Yeah. Sorry. So what about the acknowledging the XDCR? That's a very good question. So right now we don't have that. So one of the feature we want to introduce in future, it's in the roadmap, is basically to have this, the replicate to, not only replicate to the intra-cluster, but also cross-data center replication. So what's the current solution? So right now it's eventual consistent. On the XDCR, it's eventual consistent, but we have conflict resolution. So basically, if you have, I'll talk about the XDCR. We have multiple, there are two topologies we can support. It's a unidirectional replication where the backup, the cluster which is on the remote cluster, it's a backup cluster, right? So there's nothing we can do there. So it's basically you're dumping the data there. But if we have a bidirectional replication, then we have a conflict resolution. To in case if the same key gets updated, we do the conflict resolution. I'll talk about that one. So the next architectural piece, which is very important for the high availability, I want to point it out. Again, this was introduced in 3.0. Not entirely, but we also had a bit of this in the previous version in 2.2. Basically, the idea here is like we want to efficiently make use of your entire system, right? If you have a hardware, let's say if you are running on a very, very powerful machine, it has a 24-core processor, right? We want to make sure that we efficiently use the entire resources, right? So the way what auto-tuning shared thread pool does is like when you install a Couchbase, when you start it for the first time and install the first database, it goes and figures out how many CPUs are installed on this machine, right? And right now, when you do the data service, all the servers in a cluster has to be homogeneous in the sense they have to have the same hardware spec. And I'll talk about the multi-dimension scalability, which is a bit of different. But in this case, it goes and figures out how many CPUs are there. Depending on that, it basically creates multiple threads, right? There's an algorithm. We find out how many CPUs are there and I'll allocate that many threads. Why this is important for high availability is basically now you have a pool of threads readily available to take on any task, right? So imagine like in all the background operations, which is like you do a background fetch, or you do a rebalance operations, or you warm up a server. All this needs a horsepower, right? The shared thread pool is basically giving them the horsepower to do those operations, right? Because you have a bunch of threads readily available, now you can parallelize the whole work. You can basically bring back the server into the cluster immediately. One comparison we did with the previous version, which is 2.5, when we didn't have this like shared thread pool, and when we introduced in 3.0, it was almost 3x much faster to bring back the server to do any operations in the background operations in Couchbase Server. And this, as I said, this is important in terms of high availability because you can do the faster rebalance, faster node reactivation, and also in terms of durability, persisting to the disk or writing to the replication. So rebalance operation. So Couchbase Server has scale-out architecture, right? Basically, you have a node, multiple nodes in a cluster, and your data is evenly distributed across the to the cluster. Now, in the scale-out architecture, you can imagine when you want to add more servers, or you want to basically remove some servers, or do a failover, or any operation, rebalance operation is inevitable, right? It's basically the data movement has to happen because it's a distributed system, and there's a huge dependency on the network, right? So the rebalance operation in the scale-out architecture is inevitable, but we want to make sure for our high availability, we want to make sure that the goal here is to bring back the cluster to the optimal health, right? So the idea here is when you do the rebalance operation, it can be adding a nodes or removing a nodes or doing a failover. In any of this case, we want to bring back the cluster to the optimal health. The idea here is like the rebalance operation should not impact your availability. Let's say going back to the original example, it's a Black Friday sale or it's a Cyber Monday sale, and your bunch of your users, your customers are on the one of our page. You need to add more servers to increase your capacity. You start the rebalance operation. Now, if there is a latency or there's a performance impact or if there is a downtime, then it's a bad experience for your customer, and there's impact to your business, right? So the idea here of the rebalance operation is to bring back the cluster to the optimal health. The way we can do that, way we achieve this is by with the DCP now, which is the rebalance operation is a consumer of the DCP and much more efficient. It's a incremental rebalance. So we know for sure how much of the data has to be sent to the other servers, and it does in a batch processing. And also, if there is a failure, it doesn't start from the scratch. It basically knows exactly where it left off because we have ordering, and then start from there. So it's basically very efficient. And the rebalance operation now, when we compare with the older versions, it's 100x much faster with the DCP. And again, all this test we have done in-house on our own workload. When you test it on your workload, it might be even much better, or we can see different results, right? But the idea here is like rebalance operation is now based on the DCP, and it's much more efficient. So failover operations, which is for the fault tolerance, right? When you have a big cluster, if you have like 10, 20, or hundreds of servers, if one or two machine goes down, right? As I said in the beginning, the key principle is to detect the failure and recover from the failure. The way we achieve this is basically you can configure on a Couchbase cluster a automatic failover. The automatic failover happens only for one node, and there's a very good reason behind it, right? We want to avoid the cascading failure. And also, for the auto failover, we want to make sure that it goes to multiple constraints. The reason we have constraints is basically to make sure that it's not a false alarm. If there was a network glitch, and if there was a small blip in the network, we don't want to basically take an action because your cluster wants to be. It has to be so in case if there is a small blip in the network, and you take the server out, you lose some capacity. So we want to avoid those situations, right? So we have multiple constraints, and when the server is completely down, it's not responding for 30 seconds, and when there's no heartbeat going on between the servers, only then we take an action of taking the server out, right? You can still override. Let's say you're monitoring your cluster very actively, and then you get an alert saying that one of this node is not pingable or there's no heartbeat going on. You can take an action, right? You don't have to wait for 30 seconds. That is for the automatic failover to happen. But if you know for sure that this machine is not accessible, or for some reason it's down, you can take an action yourself. You can basically go and do a failover. So we have multiple options for failing over. We have an option for graceful failover. The idea behind the graceful failover is basically, as I showed in the diagram, when we do a write operation, some of the data is in memory, and it gets replicated to the other servers. It gets persisted to the disk, right? So when we do the failover, there is a very slight chance that some of the data might have not been replicated. So when you do the failover, we don't want to lose any data, which is in-flight data, right? So that's why we have provided something called graceful failover. What it does is it gives you a guarantee that none of the data which is in flight is been lost. It basically gets replicated or persisted. Only then it takes the server out from the rotation, right? So that's the whole idea behind the graceful failover. And then also, basically, we can configure all these options using our admin UI. using our REST APIs and CLI commands, right? All this is configurable. You can change the automatic failover configuration. So all this is done through the admin UI and REST APIs and CLI commands. Sorry, good. Yeah. Sorry, can you repeat the question? So that's a good question. So the question is like when you have a cluster of nodes and if two node goes down, right? So in this case, as I said, the automatic failover happens for only one node, right? But we do have the monitoring and alerting system, right? So any such events, the alert will be, if you have subscribed for the alerts, it will be sent to you as an email or as an email, SMTP email, right? So as soon as you get an email that this machine is not accessible, you can take an action, right? But if you want to reset the automatic failover, you can do it later once the automatic failover happens. If one of the machine goes down and you failover the machine, you can go back and reset the automatic failover. But it does only one for one machine. Right? Here's the same automatic failover in action. I think you might have seen this in the other presentations. Basically, here is a cluster of 5 nodes, and you have the active partitions and you have the replica partitions. These are the shards, basically, say the V buckets basically spread across all those nodes, right? So and you have 2 Couchbase SDKs running on the application servers. So at the beginning of the cluster, everything is happy. So your cluster map knows, the client libraries know which partitions are on the which machines, and they are talking to them, right? Let's say one of this machine, so one of this machine, the server 3, let's pick server 3, it's not accessible, right? So clients are trying to write to this particular, trying to reach to the server, and they keep getting timeouts, or there's a particular error message, not available, the vbucket not available, right? So they keep getting this error message, right? Along with that, all these other servers in the cluster, they have this heartbeat going on between them, right? So there's the whole idea of like the cluster is that they want to make sure that all the nodes are active, and there's a heartbeat going on. So when the other servers try to see there's no heartbeat going on with this server. As I said in the beginning, there will be a cluster orchestration, which is like a election process. In this process, one of the nodes will get elected as the master, which will start taking some action, right? And when you log into your Couchbase admin UI, you can even see from logs that one of the machine, there will be an IP address of this machine, which will start taking some actions. The actions will be, it will mark this node as down. It will mark this node as down, and then promote the replicas on the other nodes. I think it's not visible, but the replicas on the other servers to active, so that now the cluster map on the client SDKs gets updated, and they start talking to those the partitions on the other servers. The whole operation is like seamless, right? So it basically the auto failover happened. The machine was marked as down. The whole operation takes 30 seconds to happen, but you can override in case if you know this machine is not accessible, or in another case, let's say you want to do a maintenance operation. The way you do the maintenance operation is like you do a graceful failover, then you take this machine down, and then promote the cluster will automatically promote the replica partitions on the other servers as active, and they start taking the traffic. So the maintenance operation also doesn't have any downtime, right? So one of the features we added in 3.0 was Delta node recovery. Why this is important is, again, going back to the high availability, is to make sure that your cluster is in the same capacity and the same optimal health, right? So you want to bring back the node in. So when you do a failover operation, let's say it has a huge data set, right? It has terabytes of data. Now when you bring back, if it starts from the scratch, in the sense it has to catch up the entire data set, it's going to take a lot of time, right? And that's affecting your capacity. So when you do a Delta node recovery, the feature is what it provides is it doesn't do an entire data resync. It knows exactly where it left off. Let's say that your machine was taken out for 10 or 15 minutes, right? So it knows exactly where it left off and starts catching up from there. So this is a great feature because you cut the time to bring back the server to the cluster in literally in minutes or even in hours, right? Whereas if it was to do a resync of the entire data, it would have taken a multiple hours, right? So the idea again is to bring back cluster to the capacity so that you have the availability. So now I'll go on to the next thing, which is the Ragzone Awareness. I did talk a little about the Ragzone Awareness. The idea here is, even if we have a data redundancy, right? You have a duplicate copy of a replica copy of your data in the same cluster. Even then, when you multiple servers goes down, you still lose the availability, right? So let's say 1/3 of your the rack 2 goes down, and then you lose a lot of multiple servers. You lose a bunch of your data set, right? To avoid this, we have a Ragzone Awareness feature. The idea here is like you basically group the servers in a server group, right? And you know the placement of your servers, so you know exactly which server is going to which rack. So basically, the way you do it is like you can put the 3 servers in each rack, and then the way we organize the replicas is like the replica of rack 1. So all the servers in the rack 1 are not in rack 1; they will be in rack 2 and rack 3, right? And so in case if the rack 2, the whole rack goes down, we still have the availability of the data, right? In this example, I think we have created 2 replicas. So you can see that there is a blue on rack 1 and rack 2 and rack 3. So if the rack 2 goes down, or even rack 3 goes down, we still have the entire availability of the data set, right? So that's the whole idea of like the high availability, which is like you want to make sure there are different failure domains, right? The failure can happen at the one machine level, a component level, a machine level, or it can happen at the rack level, right? So we want to be prepared for that availability also. So that's the Ragzone Awareness, which guarantees you that in case if this rack goes down, you still have the availability of the data. Now let's talk about some cool stuff about 4.0, right? I'm going to spend a little time on this, but tomorrow I have the same presentation, deep dive into multi-dimensional scalability in the architecture track. The idea of the multi-dimensional scalability is we had one single workload for everything, right? Before we had a workload, one workload for data, for index, for query, everything was one single workload. Now we started isolating them. The whole idea of isolation gives us a lot of flexibility. So now you can basically do a placement of query services on the 2 nodes, index service on 2 nodes, and the data service on the other nodes. By this isolation, you can not only basically not impact the availability of the each workload. Let's say you're running a very heavy running query, right? If you are from the database background like me, so you would have come across 1 or 2 situations where there was this long running query which was taking up a lot of CPU, a lot of RAM, and you had to go and kill it, right? So in this case, even if that long running queries, there's a long running query, it's not impacting your index service, it's not impacting your data service. Those are still available, right? The whole idea of your cluster is to make sure that you are completely available. Your data service is your core operations. All your sets and gets, delete, update operations are happening on the data service. You don't want to impact anything with the data service. So we want to make sure that we isolate all these workloads and not impact your data service, right? So I will talk more about the multi-dimensional scalability. I will have a live demo which shows when we add more nodes or when we do any complex join operations, when you do a multiple index build operations, it don't impact the data service, right? So resource-wise, much more optimized, availability-wise, much efficient because you don't impact the availability of the data service. So I have a quick demo here okay, go ahead. I'll take the question. No, so okay, that's a very good question. This, when I show you this diagram, it doesn't mean that you have to do this, right? Let's say your workload for index or workload for query is very minimal, right? You're not doing a complex join. You're not doing you don't have multiple indexes, right? In that case, you don't have to like isolate them. You can run them on the same machines, right? But you have to be prepared. When you run them on the same machines, when you add more data service nodes, it will also stretch the index. It will also stretch the query, right? So the performance will be impacted. But if you are sure that the workload are not heavy, then you can still do that, right? But as a cluster, you can basically start with 3 nodes in a data for the data service to have the availability, and also for the index and query, you can combine them on the same machine, or you can separate them different machines. So before I get to, let me show you the demo. Sorry. All right. So I have set up a quick, say, cluster of 4 machines. All of them are running the data service, and you can see from here that all of them are running the data service. And to answer your question, I have one more machine I can add to the cluster. Let's say this is the machine. I want to bring it to the cluster, and I don't want to make this as, let me add the password. So I don't want this as a data service. I want to run this as an index service, right? So I can add the servers to the cluster. So it will get added as a, and this is because the first time you create the cluster, the index node, you have to give the RAM quota for that. So here, let me add another server, which is a query server. And query and remove the data. So when I do this, this machine is not accessible. Sorry. Okay, I think let me add this one server so that I don't take up time. So you saw that when I did a rebalance operation, it was very quick. The reason is like there is no data movement, there is no cluster map changes, there is no partition move. So the whole operation was like fairly quick because this is a index service. Nothing else is running on this. It's basically the index service. So it gets added, and you can see from here that it will say the index, the services running on this node is index. You can run multiple services on the same node also, right? One thing which I would like to show is on the settings page, you have basically auto failover, right? You need to specifically enable this, enable the automatic failover. And right now, the timeout default is 120. You can change it to 30. It's accepted. But if you want to change it to anything below 30, it will give you an error message. Because we, as I said in the beginning, that we need to go through multiple constraints to make sure that this is not false alarm. So we need at least 30 seconds to figure it out. But if you don't want, as I said, if you don't want to wait for 30 seconds, you can still do a manual failover, right? So you hit save, and if I go back to server nodes, and let's say the failover option I wanted to show, so it will basically give you the 2 options, which is graceful failover. If you want to make sure extra guarantee that there is no data loss, you can pick the graceful failover. But if you are sure this is a maintenance operation, there's no traffic happening on this node, you can pick the hard failover, and then it give you error message saying, warning message that if there's any in-flight data, it might get lost, right? And then you hit the failover, right? So failover operations, even when you do the failover, it will give you these 2 options to bring that node back to the cluster, which I was talking about. If you know that server was taken out for like 10 minutes or 15 minutes, and for the maintenance operation, like a security patch or any like software update, and now you want to bring it back, right? And this is one of the way we can even do a upgrade to the new version, right? Let's say you are on 3.0, 3.x version, and you want to upgrade to 4.x version. So basically, you can start doing the failover and bringing back the node. Alternatively, you can do a swap rebalance also, which is much more efficient. Yes. That's right. So basically, when I say when I added the node, the index node, say there is no other activity, right? So the reason is like that node has no partition map. In the sense, like it doesn't have any data partition map. So it has only the indexes running, right? So when you do a add server for the cluster and I bring a index server, it basically says that this node has no data in it. It has only the index services, but it doesn't even have, I mean, once you bring the server in, only then you start creating the indexes, right? So for now, when you bring the server, it has no partitions, data partitions, so no data rebalance has to take place, so it gets immediately added to the cluster. The same with the query services, yeah. You have to specifically create it. So right now, if you see that I don't have any indexes created, it's empty, right? When you bring the service, so to create the index, you need to have at least one machine running the index service. And that was my first machine. Okay, I think I will take the question later because I think I'm running out of time. I'll switch back to the presentation to show you the the next part, which is the disaster recovery. And I have a quick animation which shows you that you have geolocated clusters everywhere in the globe, so that you want to have geo redundancy, right? So I talked about XDCR, which is like you have like 2 Couchbase clusters, and you can set up a unidirectional replication, you can set up a bidirectional replication. And each of there are different use cases for each of them. So you can create a hot spare or a like standby cluster. You can do it for development or testing purpose. Also, you can use another cluster for data center locality, for multiple active masters. All are different use cases for the cross data center application. But the whole idea of going back to our initial example, the idea here is like to have, in case of a catastrophic disasters, we want to have geolocated data. So in instance, like you want to have data redundancy on the geolocated place, so that in case if this whole data center goes down, or the whole region goes down or zone goes down, you still have the availability of the data. There are a bunch of things about XDCR, which again, not anything new in the 4.0, but one which is new is filtering of data, which is one which had been a lot of customers, a lot of users have been asking about it. And I'll quickly show you the diagram here. The same action is basically the document comes in, it gets sent to all those queues, right? It goes to the replication queue, XDCR queue, persistence queue, and gets sent. CV backup and restore, we have backup restore. This is basically a oops case where you make a error, you by mistake delete a data, or you by mistake flush the bucket, flush the database, right? That mistake also gets replicated, right? Because you have intra-cluster replication, or because you have the cross data center replication, that mistake also gets replicated, and that will basically, you lose the data everywhere, right? How do you recover from there? Is basically you need to have backup running, right? You need to back up your data constantly, so that in case of such kind of mistake happens, you can recover back the cluster. The backups are consumers of DCP again, and much more efficient. We have 2 options, which is differential and cumulative backups. You can take a incremental differential backup, which is basically any changes which happen from the full backup, and it's a delta. So it's much more efficient to run, and also it's a time, in terms of time consumption, it is much shorter because it's taking the delta of the backup, right? So I'll go back here, and I want to quickly show you the XDCR, because this is the important part. So setting up XDCR is very simple, like 3 steps. You need to know the destination cluster's one IP address. In this case, I have an IP address of the destination. Let's pick this guy here. Okay. So IP address of the give the network data center. Sorry. Sydney, for example, IP address of that machine, password. All you need for XDCR, to set up the XDCR, is like one IP of the destination machine. It will go and figure out the topology of the destination cluster. So it knows how many machines are installed, what partition is in what servers, right? Setting up the replication. In this case, I'm going to do a filter replication because I have less time. So I have a travel sample bucket, and I have already created the reference. So I'm going to create the destination bucket name is airline. I want to enable the filtering. So before that, I want to show you what data we have, right? So travel sample data has a bunch of airline information, airport information. It has the flight details. It has the routes and everything. I want to replicate only the data, which is subset of the data, which is airline data to the destination, right? The way I can do this is using XDCR filtering, and here is the filtering XDCR Fini, airline, and enable filtering, put the cap airline, right? And if I want to test it out, I'll say airline underscore 123. And then if you see it matches, it's fine. So it starts replicating. Sorry, I think something happened here. Replicate. Actually, okay, hold on 1 second. Okay, so I think it replicated. It didn't show up here. It's a beta version, so I think you need to bear with me. So it shows up here that the replication has happened. But you can see from the destination that data has already replicated here. You can also basically go to the airline, go down to the stats and see that there was a incoming XDCR. There was 187 documents got replicated here. Okay, so I think I'm done. So you have any questions for me? I can take the questions now. All right, yeah.
So for the view right, so
yeah.
with the sweep and all the stuff, the view right, right?
Yeah.
And again, handle the failure and the exception.
Let me come in offline with you. Sorry. Sorry. What was the question?
So if we need to guarantee the data